Hi, I'm Carl Leverage from Extra Cheesy Games, and today I want to do a tutorial on how to colorize a character. And I'm going to do about the most basic version of this as I can present. So let me just show you what we're going to work on here. So I've got a character in Humans Must Eat. This is a customer, and what I've done is I've made a shader that I can put a color on and just colorize a part of the character. Now, obviously, you'd want to pick colors that might make more sense for a character. And you'll notice that the hair and the body colorize the same. Now, at runtime in the game, the head and the body, even though they share the same shader, I will drive their colors separately through a script, right? So when the character gets instantiated, I will randomly pick a color. And all I do to do that, now that I can do this within the shader, is I will send down the shader the color that is going to be presented, just like what I'm doing here in the editor, but the editor is doing the whole thing. So let's show you how this is done, and let's begin with a little bit of simple color math. If you take the color red and you multiply it against the color black, you will get the color black. That's because 255 times 0 equals 0, 0 times 0 is equals 0. So the math is very basic. If you want white, if you multiply red against white, you get the final color. And if you multiply your red against a tonal map, you will get tonality of that particular color or different shades of that color. Okay? So that's the basic math you need to understand to colorize. Now this is the map that I'm actually using for the character, this part that's highlighted. And you'll notice that the shirt is white, and I'd say it's grayish. And like I was showing you in my math on color, a gray color against your color will produce a tonal white, which is exactly what I'm getting inside of here. I'm getting those little flecks on his shirt and so forth, right? Now, the magic, though, occurs down in the alpha channel. The alpha channel I just paint in what I'm going to colorize. What's black will be protected against colorization. What is white will be colorized. It's pretty basic stuff. And this is just a one-channel color scheme. I could have colorized his pants and his shirt by doing some different and a little more complicated version of the shader. And just to kind of show you, I mean, this is actually a good example where maybe I could have gotten away with vertex color and did it without it because I broke the polygons right there. But if I was to come inside of here and identify this, I could paint out his hands. Just guess where their hands are. Normally I do this in a program like Substance Painter. And if I save that and I come in here, you'll notice that the hands get colorized like matchsticks. Okay, so that is how that is done. Now, let's look at the shader itself. I've got two versions of the shader. This version over here is a surface shader. This version over here is a vertex fragment program. Now, all I'm doing is I'm piping in a color that'll allow it to be colorized and the texture. All right. This is just a Lambert shader and defining the variables inside of here for the being used in the CG program. And now here's where the magic begins. So the first thing I do is I read the color into a variable called C. Then I make a new variable called colorized, and in that one I actually take the color and multiply it. So the whole thing got colorized, right? So now if you wanted to see how that worked, I can actually, and this is a very common thing I do inside of a shader to test my work, is I'll just bypass the final summation and I'll just put in what I want. So now I can see that is what the character would look like if he was entirely colored. So that's what's getting piped into colorized. But this is the magic statement right here. This one I'm actually lerping, and a lerp stands for linear interpolation. What that means is I'm taking a value, color A, and taking color B, and based on some percentage is what equals the result. Okay, so I am saying at one extreme is the value 0, if I say that, and look at this, now I get the color of him the way we saw it before. And if I say the value of 1, I'm getting the extreme version again. But because we're driving it through our alpha channel, I'm getting what we'd hope to get for colorization. All right? So that's one technique of doing this. This is the simplest one, although I will say that oftentimes with this, I get halos. And I learned a new technique I'd like to share with you here. And this one's a little more math intensive, and I should have sat and practiced this math, so I'm going to do it off the cuff here, and hopefully we'll do it right. Instead of colorizing this entirely like you saw where the whole thing was the color red, let me say colorized equals color times actually I should make that, I won't do it for now, but times color times C dot A. Now, one thing that you can do in a shader, and I actually should do this, I sometimes just get lazy and don't do it. I should say this is diffuse, and I should say mask equals diffuse A. Now, when I use this stuff, I'm not making these cryptic statements. I'm saying diffuse times the mask. And you know, it actually is a lot easier to read. So my colorization is diffuse times color times mask. So what's going to happen here, if I look at this, let's just build this up a piece at a time, and so you can see what I'm building. And this is how I build shaders, is exactly what you're seeing me do here. So now you see where I don't want colorized has gone black. Okay? Now, what I want to do is I'm going to take my color equals diffuse times 1 minus mask dot 1 minus mask. Okay? Now, if I look at this, should have the inverse of that. Okay? Now, to get the color, all I've got to do now is say color equals, the final color is plus colorized. All right, now let's look and see what we got. Perfect. All right, so let's look and see what happens when I'm hitting these values. See, now I've done something wrong. Can you guess what it is? I know exactly what it is. I forgot to do the channels right. So I did colorize. This should be fixed 4. Oh, thank you, mono development. Every so often you'll find that mono development is not your friend, and it just crashed. So I'm gonna do a preemptive strike here. I'm gonna force quit mono development. You are going away. Nice thing about working in shaders though, you're writing code and you're always saving, right? So if it crashes like that, all I got to do is reload it. As long as you saved it, you got it back. So shaders are pretty forgiving about crashing on you. So the problem is I made this a fixed, which is a single channel. This should be 4, and this should also be 4 because I'm reading all 4 values, right? So let's see what we got now. There we go. Now, I still have this bleeding here, and this is not, what this is caused by is it's just a sloppy mask, and I think what I would need to do in here is go in and clean this up. Now, why would I use that technique over the other one? I've actually found, let's look at the difference. Let's see what we see that looks, if it looks any better or worse. Let me make sure I haven't made a mistake on the math. I don't think I have. Other times red. Let's comment this version out. Put this one in. Let's see how much of a difference this is. That's a lot different. So colorized equals color. Video equals alert colorized. Now see now I got to change these numbers around. This is what happens when you start renaming things. You got to make sure you refactor all your code. This is diffuse. This is mask. Okay. There we go. So that's that version. Let's take a snapshot of that, shall we? It's the first one, and let's take this one. I'm actually running my mouse on my Wacom tablet, and that tends to make this a little bit sticky. That's interesting. That's a little more black, and I know that's got to be a mistake because they should look almost identical. Let me see here. Mask, 1 minus mask. So I'm taking and inverting the mask. Color equals. So let's just look at this. Now this is making shaders right here where you see a problem and you got to go, why is it doing that? Okay, that's that one. Colorized. It's interesting. One thing the reason I'm showing you this is I've actually found this technique where I'm adding the color to be much more, what's the word? You get halos around the lerp version that I don't see with this colorized version. Where I knock out the mask, because all I'm doing is I'm taking the color where it's going to be colorized, I'm knocking it out to black. That way when I add a color, I'm starting from black, adding in my color, and it looks fantastic. But I'm wondering if this is actually more representative of what that looks like. I don't think that's right. Diffuse times color. Let's do this. Actually, I think this is the problem. The math order is wrong here. Is that right? No, that don't work. That should work. Diffuse times mask. Let's take out this. And I just redesigned the shader around this till I finally see what's going on. It's interesting, because it doesn't look that dark. Times color. Now I add the color back in. It's almost like this one is not. Let's look at the color. Oh, this is the problem right here. Yeah, okay. So you got to pay attention to that order. I bet someone was sitting there screaming at their screen, "You're doing this wrong, dummy!" So by doing the math wrong, what was happening is I was multiplying diffuse times 1 and then subtracting the mask. That's not right. I need to invert the mask, then times it by the diffuse. Okay, so now that's what I'd expect. Now let's look and compare these again now that I've fixed my mistake. And the same rules that apply to math when you code in C# or C++ or whatever applies inside of a shader. The same rules about the way math gets interpolated and so forth. Let's take that one and look at it. I think those look identical, actually. I should have taken a screenshot of it. I did, but I got sidetracked there. Yeah, they're identical. But I understand that this version is faster. I don't know. I can't clarify that. I don't have an easy way to tell you if those numbers are right. This one up here is a little cleaner looking to me, but this one also, there's been times when it makes more sense to go through and knock out stuff and add it together. But that's in essence the way this works. Now, let's say you wanted to do two-toning or three-toning. The same rules would apply. Oftentimes, you'd repurpose a mask instead of like using the alpha of the map of the character or whatever as a single channel. You might actually dedicate a whole texture where your RGBA might be masks, and you would go in and multiply colors across those masks to come up with the final. I'll do a demo in the future about how I two-tone a car and show how that changes it up. But that's in essence the final thing about how I tone up characters. It is always just a variant of that. There's other ways to do it, but this is a very simple way to do it, and it's pretty effective, especially for mobile games. I feel like it looks pretty good. So with that, I'll close, but hopefully you've learned something new about shaders. You know, I'm hoping you're also kind of watching as I'm debugging these, because shaders are very... I don't know what the word is, cryptic. They're hard sometimes to understand why they give you an error, and there's sometimes some weird things that'll happen. They're not very friendly to debug. Oftentimes, you just see it doesn't work. That's your result. You may not get any errors. And I do think editing a surface program is the culprit why sometimes I can't tell what's going on in there. Surface shaders, they don't air out the way a vertex fragment program does. And I think the reason that is because this thing can fall back onto this diffuse. And that's probably one of the reasons it does. If the shader fails, it falls back on this. And when I typically write a vertex fragment program, there is no fallback. In fact, let's just test that theory while I'm here. Let's take off my fallback, because that's the fallback shader in case something goes wrong. So let's say, I left the semicolon out. Let's see what we get. Nope, see, it's still not pink. That's still not pink. I think somehow this thing is doing, it's saying, hey, that failed, but I'm going to make something work for you anyway. Just because I like you. That's what I think it's doing. But that's interesting. Shaders are a mysterious beast sometimes, but hopefully you got some ideas there that'll get the juices flowing. If you want to write a shader to do some colorization, here is the vertex fragment version of that. You can pause the code and look at it. I'll put this code up on the on my website so you can get at it, so you can compare it. So with that, I'll go ahead and close, and thanks for watching.